Hello and welcome everyone. So welcome to another extra section. In this video what we are going to do is understand how to use gameplay effect execution calculations. So these will be useful when you want to perform some complex calculations on your gameplay effect. And in this example what we'll be doing is actually our player is going to have an armor as well as health. So if the armor is equal to 0, then we will start taking damage on the health and we're going to perform those calculations. So for this what you want to do is go to file and create a new C++ class, and we're going to search for this gameplay effect execution calculation. Hit next and change the name to GEXEC, and we're going to just call this for melee. Okay, hit create class. Now we're going to return to this video once this compilation is done. Okay, so our compilation is done, and first what we're going to do is navigate to our base attribute set class, and what we're going to do is actually add a few attributes for our armor. So I'm going to do is actually just copy this over here and I'm going to paste it twice, and first one is going to be our shield and next it is going to and this one is going to be max shield. Okay, and what we're going to do in the CPP file is add our clamping. So it's going to be data dot evaluated data dot attribute, and if it is equal to our shield attribute, okay, what we're going to do is set it, and it's going to be fmath and not this one, and we're going to clamp this, get shield, and it's going to be between 0 and max value like this. Okay, and now let's actually move to our melee calculation class, and going to our header file, what you want to do is first of all we're going to declare the scope as public. Okay, and then I'm going to create a constructor for this. Just copy this and paste it over here with the brackets, and then I'm going to create a new function that's going to add some modifiers for our attributes. So it's going to void execute implementation, this one. Okay, it's going to take a few arguments. It's going to be f gameplay effect custom execution parameters, and this is going to be passed by reference, and it's going to be called exec params, should be capital. Okay, and it's going to take another argument. It's going to f gameplay effect custom execution output. It's also going to be passed by reference. I'm going to call this exec outputs. Okay, and this is a const function. Okay, this is done. Now we're going to implement our constructor first, and I think we need a few header files over here as well. Yes, we need to include our base attribute set class. It's going to be base attribute set.h, and before I begin my constructor I actually want to capture or snapshot these attributes for use in my calculation. So I'm going to define a struct for that. So it's going to be struct, and I'm going to call this damage capture. Okay, and over here what I'm going to do is use macros to capture our shield and health attribute. So it's going to be declare underscore attribute capture def, and first one is going to be shield. Okay, and we're going to also capture our health. So it's going to declare attribute capture def, and it's going to be health. Okay, and I'm going to also create a default value for this. It's going to be damage capture, and to define these values, define attribute capture def, and it's going to take u base attribute set, and first one is going to shield, and it's going to be for the target, and we're going to snapshot it true, and just copy this again. So it's going to define attribute capture def, and it's going to be same u base attribute set, and it's going to be health this time, and health of the target, and it's going to be true. Okay, and so what other option for this target is source. The target is the effect is applied upon, and the source is the one that is actually casting this gameplay effect. So in your calculation you might need to differ this for your own example, but since we are applying damage to a target, the enemy, so we're going to need their health and their shield values rather than our own for this calculation. Okay, just remember this difference. And I'm also going to define a static function which is going to return us these capture attributes. So it's going to be damage capture, and this is going to return us, we're going to call this get damage capture. Okay, and I'm going to define it as static damage capture, and it's going to be called damage capture variable, and we return this variable. Okay, so our function is done, and now inside of our constructor for this, what I'm going to do is actually capture these attributes and store them inside of our relevant attributes to capture array. So we're going to begin by typing relevant attribute to capture relevant dot add. Okay, and I'm going to say get damage capture dot shield def. Okay, and I'm also going to capture our and attribute to capture, and it's going to add, also getting to get damage capture, and I'm also going to get our health step. Okay, I misspelled it somewhere, so just let's copy and paste this. Okay, it's fine. And also going to add a temporary variable that's not inside of our attributes, but I'm going to need this for my damage calculation, and this could be like base damage. You can add some base damage or damage multiplier attribute inside of your attribute set and then set it as source, because source is applying the damage. But I have chosen to use a temporary variable for our calculation. So to use a temporary variable, what you do is say valid transient aggregator identifiers, and then just say add tag, and for this I'm going to just use the constructor to create a new tag. So fGameplay tag, and I'm going to say request gameplay tag, and I'm going to pass in a string that's going to be character dot calc for calculation, and it's going to be damage, and it's going to be melee. Okay, so I'm going to add a comment over here just so that you remember this. Remember to add this tag inside of your project. Okay, so this tag is not automatically added to your project. You need to manually add this and compile this inside of your project. And okay, so our function is done. Next we want to implement this function execute implementation. This is where we do our actual calculation for damage calculation. So starting off, what I'm going to actually do is define some variables. First we are going to say some for calculation variables. Okay, so it's going to be float, and I'm going to call this out health and initialize to a 0 value. Okay, and next it's going to float out shield. It's going to be also initialized to 0 value. Okay, next I'm going to store some these capture attribute inside of variables. So it's going to be capture variables. These are just comments, don't worry about these. Okay, float. First we need our shield magnitude. Okay, shield is going to be also initialized to 0 value. And next I'm going to need our health magnitude. Health magnitude, okay. And next I'm going to get our attack damage. Now this variable is not present inside of our attribute set, but we're going to get this attack damage value from this transient aggregator. Okay, so I'm just creating a temporary variable inside of C++ for this value. This is going to be retrieved from the blueprint gameplay effect class. Okay, and after this I'm going to actually start capturing these attributes and storing them inside of these variables. So you say begin by saying exec parameters dot attempt calculate LC attempt calculate capture attribute magnitude. Okay, and I misspelled it somewhere. Not the base value. Capture attribute magnitude. This one. Okay. Inside of this we're going to say get damage capture, and we're going to first get our shield definition, and we're going to pass in the constant parameters for this aggregator. This one, this is the constructor, and next I'm going to pass in our shield variable, so it's shield magnitude. Okay, and next I'm going to copy this and do this for our health depth. Okay, this one, and this is also going to be our health magnitude. Okay, and I need one more for our attack damage, but it's not going to be captured attribute. Is going to be actually attempt calculate transient aggregator magnitude. Okay, this is not a capture attribute, this is a transient aggregator magnitude. Remember this, and over here I'm going to say f gameplay tag, and I'm going to request the same tag, request gameplay tag, and it's going to be the same one. So I'm just going to copy this like this, paste it over here, and then it's going to take our same argument, this one, and after this I'm going to pass in our variable. This is going to be attack damage. Okay, so we have captured our attributes and stored them inside of the variables. So I'm going to actually start our calculation. Okay, so what I want to do is actually subtract our attack damage from our shield, and then decide if the shield is already 0 or if the damage is too much for the shield. We're going to deduct this damage from our health. So I'm going to say out shield is equal to shield magnitude minus attack damage. Okay, and then I'm going to check if the shield is below 0. If out shield is less than 0, what we're going to do is actually say out health is going to take the damage for the remainder of the shield. So we're going to say health magnitude subtracted by our out shield value, But remember, in this case our out shield value is negative, so what you could do is add this or just take the absolute value of this. So for the absolute value I'm going to stick with that, so it's going to f absolute, and I'm going to use this. Okay, and I'm going to forcefully set our out shield equal to 0. You don't need to do this, but it's a good thing to do over here. It's also being handled inside of our base attribute class, and it's clamped over there, but yeah, we're going to do this over here as well. And after this I'm going to say exec output, and I'm going to add output modifier, and it's going to be f gameplay modifier evaluated data, and it's going to be get damage capture, and going to be shield property, and I'm also going to say gameplay mod op, this one, and I'm going to say override, and it's going to be out shield. Okay, and I'm going to copy this and change this for our health property. Okay, and it's going to be out health. Okay, this is done, and if this is not below 0, I just want to simply deduct this damage from our shield only, if our shield is enough to take the damage. So what I'm going to do is just copy this out shield line and just paste this over here. Okay, so I think our code is done, and what we can actually do is go to our base character class and create a function to get our armor or shield values. So I'm going to say u function, and this is going to be blueprint, rather let's change this to blueprint pure, and its category is going to be base character. Okay, and I'm going to name this void get shield values. Okay, and it's going to take a few arguments. It's going to be shield, and this is going to be passed by reference, and next we're going to say float and get max shield. Okay, now let's create an implementation for this as well. Go to your CPU file, and I'm going to say shield is equal to base attribute set component and get shield, this one, and max shield is going to be equal to base attribute set comp and get max shield. Okay, so this is done. Let's try to compile this, and we're going to return to the video once this compilation is done. So our compilation has completed successfully. Let's go to debug and start debugging to start the engine. And once this is loaded, we'll return to the video. Okay, so our engine has loaded, and first of all what we want to do is go to our characters folder and initial data table, and we need to add those shield and max shield values. So I'm going to add those shield, and shield is going to be 100, and max shield is also going to be 100. Rename this to max shield. Okay, and this is also going to be 100. Save this, and next what we're going to do is actually prepare our enemy character to show us the health as well as the armor. So go to user interface, enemy health, and what I'm going to do over here is add another progress bar. I'm going to duplicate this and just rename this to shield. Okay, and this is going to be 0, 0. Offset it a little bit. Okay, and I'm going to create a new function for this one. Where is it? Let's change the color as well to something like yellow. Little bit of difference, and our percentage is this one. Yep. And I'm going to create a new binding. I'm going to say get this order and say get shield values, and I'm going to divide these values, plug this in over here, and this should be good to go. Next, what I want to do is go to our melee ability and create a new damage class for our GA melee. Okay, so just for the ease, I'm going to duplicate this and I'm going to call it GE melee damage exec for execution. Open this up, and if you see over here, we already have our modifier that modifies our health by a certain value, like -10 in this case. What I want to do is actually delete this and go to our execution and add a new value for this one. Over here, what you should see is we have a calculation class, and over here we have our GE exec melee, and now we can add our calculation modifiers over here. See over here we have our shield and our health, but we are missing that temporary variable that we used for our tags. To expose that, what you want to do is go to your project settings under the gameplay tag section. This one, you're going to add a new gameplay tag, and I'm going to add that same gameplay tag, character calc damage.melee. Add this tag. Now what you need to do is actually close the engine and then restart it for this to work properly. So that's what I'm going to do. Okay, so our engine has loaded up and we are back inside of our GE melee damage exec class. And now what you should see under this category, we should have another temporary variable against the gameplay tag, and you see inside of our calculation we have this tag applying to this attack damage variable. You can have this attack damage variable as an attribute, but in our example I'm just going to use this as a temporary variable to apply damage, and then it's going to perform the calculation on our shield and our health. Going back, what I'm going to do is actually set this to override, and I'm going to give it a value of positive 20. Now I'm giving it a value of positive 20 because if you see inside of our calculation, we are actually subtracting this from our shield magnitude. If this was a positive value, then we have to give this attack damage a negative value, but in this case we are subtracting, so over here I'm giving this a positive value. Compile and save this and go back to our GA melee, and I'm going to tell this GA melee apply gameplay effect class to use our melee exec for our damage calculation. Now what you should see is that our enemy has his armor in yellow and his health in red. When I attack him, his armor is decreasing, and when his armor is 0, he starts taking damage on his health. Okay, so in this way what you could do is perform some complex calculation for some poison effect or stacking debuffs or speed debuffs, slowdowns, this kind of stuff, and you can perform some complex calculation and modify more than one attribute from a single gameplay effect. So, but the problem with this is that this has to be done inside of C++. I'm sorry, there's no way to do this inside of blueprints as far as I know. So this is just one way to do this, and I just want to give a little bit of an explanation about how to use these. Is first you declare your structure for the attributes that you want to capture. In our case it's shield and health, and for this source and target, like let's just say for example you had an attribute attack damage. Instead of this temporary variable, what you would do is declare this as a capture def. Let's do this. I'm going to say over here like attack damage, and over damage capture default values, what you would do is copy this, and what you would do is use that base attribute set as is, and you would say attack damage, and then what you would do is actually use the source instead of the target, because we want to capture the attack damage of the source, the one that is applying the damage, not the target. Target could be like a 1 level enemy, and our player could be like level 50. So we want to calculate the damage, attack damage of our player instead of our enemy. Enemy is the target in this case, and our character is the source. So just be careful of the source and target. And the last one is just snapshotting. So that should be true in most cases, because if you have some sort of running kind of attributes that are constantly changing values, in those cases you would use this as false. I haven't seen a case in my experience that uses the false case. So, but just to show that you might require this, just remember this. And so yeah, this is it for this video. And I think this covers almost all of these topics that are required to use Gameplay Ability System effectively inside of blueprints. So this is it. Thank you very much.